Let's read the question. Show that the circles x square plus y square minus 6x minus 2y plus 1 equal to 0, x square plus y square plus 2x minus 8y plus 13 equal to 0 touch each other. Find the point of contact and the equation of a common tangent at their point of contact. So if you understand this question, this is one of the equation of the circle and this is the other equation of the circles. So here are the two circle equations. So suppose if we have to say this is the first equation of the circle, I can say this is the first circle and this is the second circle. So first equation is representing the first circle and the second equation is representing the second circle. So the question which they are asking us to find out is that they're saying us to identify whether these two circles were touching or no. Okay, if they are touching, then we should even find out whether these two circles were touching externally or internally. So what is external touching? Suppose this is the first circle and this is the second circle. If this is touching like this, so this is touching externally, the two circles touching externally. For suppose this is the first circle and the second circle is touching internally in this way. So now we got clarity that these two circles were touching externally and these two circles were touching internally. So the first point we understood is that the circles either they are touching externally or internally, and the second thing which we have to find out is that after they are touching, at which point, at which coordinate are they touching. Suppose this is the point P. So what is the coordinate, the x comma y coordinate? So that we have to find out. Even if that is internally touching, the point P which is x comma y coordinate we have to find out. And the other thing which they are asking us to find out is that for both of the circle there will be a common tangent. So this is a common tangent, so even we have to find out the point where the tangent is moving, and also we should find out the equation of that particular common tangent. So these are the things which they are asking us to find out. So anyhow, this is just a basic understanding where this is not the exact figures, as we don't know whether they are touching externally or internally. So for the reason we just take off these figures. Once we do the complete problem, then we'll get complete clarity whether they are what kind of figures we could make it out. That we'll do it at the end of the problem. So now we'll write the given circle equations are. So there are two circles given. So the first circle I'll just represent with S. So that is x square plus y square minus 6x minus 2y plus 1 equal to 0 is the first equation, and the second equation is, I'm just taking that as S dash, which is x square plus y square plus 2x minus 8y plus 13 equal to 0. So these are the two equations which were given. So I'll just represent, or I'll just compare these equations with the general equation of the circle. So the general equation is x square plus y square plus 2gx plus 2fy plus c equal to 0. So this general equation, if you have to find out the g and f, so for that the center of the circle which is represented as c equal to minus g comma minus f. So when I compare this minus g comma minus f with the general equation, and where that was compared with this 6x minus 2y, so I'll be getting here the c value which is the center of the circle as 3 comma 1. Alright, so this is the center. The same scenario even for the second circle also, the general equation I'm just comparing. So that is x square plus y square plus 2gx plus 2fy plus c equal to 0. As the center of the circle, we already know that was represented as minus g comma minus f. So the center, obviously, when we compare the general equation and the given equation, the center we are getting it as minus 1 comma 4. Alright. So now we got the center of the circle. Now even we have to find out the radius for both of the circles. So I can write here the radius as, so as this is the first circle, I'll say radius 1, which is equal to g square plus f square minus c. So here I'll just submit the g value. So the g value is 3, so it is 3 square, and the f value is 1, so that is 1 square minus the c value, we can say that is 1 is the c value. So I can just submit the 1 value over here. So let's solve this further and we'll see what do we get as a value. So this is 3 square, which is nothing but 9, and 1 square, which is 1, and this is minus 1 under root. So this is plus 1 minus 1 get cancelled, so this is root 9, which the value we are getting the radius 1 as 3. So let's do the same for the radius 2 also. So I can write radius 2 equal to g square plus f square minus c under root. So the g value is minus 1 whole square and the f value is 4 whole square minus, when we see the c value here, it was 13. So I can write here the c value as 13. So this is under root is also there. So let's solve this further. So this is 1 plus 4 square is 16 and this is minus 13. So here we'll be getting this as 16 plus 1 as 17 minus 13. So 17 minus 13 will be getting this as root 4. So root 4 will be getting the value as 2. So the first radius we got it as 3 and the second radius we got it as 2. So now we got the radius and we even got the center of the circle, and now we'll just find out the distance between the center of the first circle and the center of the second circle. For suppose I'm just finding out the distance from center of the first circle to the center of the second circle, then we'll be using the center 1 and the center 2 of the circles, and we'll be finding out the distance between these two circles. So for that we'll be using the distance between 2 points formula and we'll be getting that. So for that I can write here the distance between 2 points. So there x1, y1 and x2, y2, these are the 2 points, whereas the centers we already got as we solved above. You can just check it out. This is 3, 1, another center is minus 1, 4, where of course the distance formula is what? That is x2 minus x1 whole square plus y2 minus y1 whole square under root. So in this particular formula we'll just submit these 2 points, then we'll be getting the distance between these 2 points, or we can say the distance between the two centers of the circle will be getting. So I can write c1 c2 equal to, so x2 is what? So that is minus 1 and x1 is minus 3. So x1 is 3, but as there is minus sign, so we are just taking minus. So this is whole square plus y2 is 4 and y1 is 1. So this is whole square under root. So let's solve this further. I'll be getting minus 1 minus 3, which is minus 4 whole square, and the c is 4 minus 1, which is 3 whole square under root. So I can just further solve this. 4 square is 16 and 3 square is 9. This is under root. So I'll be getting this as root 25. So the root 25 will be getting it as the value as 5. So the distance between the center 1, that is circle 1 center, to the circle 2 center, the distance is how much? It was 5. Alright, so that is what we got here. So even we'll just check out with the radius also. So for that I can write also r1 plus r2 equal to, that is 3 plus 2. The radius of the first circle is 3 we got, and the radius of the second circle we got it as 2. So 3 plus 2, that was 5. So here the center, the distance between two centers of the circle we got 5. Even the radius, when we added both of the radius of the circles, we got 5, which means the perfectly both of the circles were touching externally. So I can write therefore c1 c2 equal to r1 plus r2, where we can say here 5 equal to 5, as c1 c2 the distance we got 5, even the r1 plus r2 we got it as 5. So if at all we have to observe these figures, so the radius here is how much? The first circle radius, suppose it was 3, and the second circle radius it was suppose 2. So when we add these both of the radius, we are getting the value as 5. Even when we find out the distance between these two centers, that is center 2 and center 1, we even got it as 5. So we clearly understood that these two circles were touching externally. So we got one point that the circles were touching externally. Alright, now we'll even find out this point of contact of these both of the circles. So we'll just go forward and we'll even find out the point of contact of these both circles. So I can write here, given two circles touch each other externally. Okay, as they are touching externally, then we can say the point of contact, that is P, divides C1 C2 internally. So what was the ratio? I can write the ratio as R1 is to R2, which is the radius, or the ratio we can say 3:2. First radius is 3 and the second radius 2. If not, we can write like this under the values, that is 3:2 is the radius which we got. Alright, so now we'll just use all these values. Even we can just using this we can just find the point of contact of these two circles. So whenever the circles were touching externally, then the point of contact we can just get it by using the formula, that is Px comma y equal to R1x2 plus R2x1 by R1 plus R2 R1y2 plus R2y1 by R1 plus R2. So this is the formula we'll use over here, whereas this is R1 and this is R2, and when it comes to the points x1, y1, x2, y2, that is first center gives 3, 1, which is x1 and y1, and the second center that will give us x2 and y2. So we'll just submit those values where we'll be getting the point where the two circles were touching. So this is 3, R1 is 3, and the x2 is -1, R2 is 2, and x1 is 3 by 3 plus 2. So this is 3, y2 is 4, R2 is 2, and y1 is 1 whole by 3 plus 2. So let's solve this further and we'll be getting the point. So I can write here 3 into -1 is -3, and 2 3s it was 6, 3 plus 2 it was 5, and 3 4s it was 12 plus 2 by 5. So let's solve this more further. -3 plus 6 will be getting this as 3 by 5 comma 12 plus 2, which is 14 by 5. So this is a point where both of the circles were meeting one and the other. So if at all we have to observe the figure, so this is the point where both of them were touching, so we can say that is a point P, where this point P, which we got it as point P, is 3 by 5, 14 by 5. So this is the point P where both of the circles were touching. So now even one more thing which we have to find out, that was the tangent, the common tangent for both of the circles. So before that we'll just write the conclusion for this point P, then we'll go for the tangent. So I can write here, therefore equation of common tangent at the point of contact P, that is 3 by 5, 14 by 5 is, so we'll now find out the equation of the common tangent. So I can write here equation of common tangent is, that is S minus S dash equal to 0. S in the sense that was the equation of the first circle, and S dash is equation of the second circle. If not, I can just write here S is nothing but x square plus y square minus 6x minus 2y plus 1, whereas S dash is x square plus y square plus 2x minus 8y plus 13 equal to 0. So let's do this, that is S minus S dash equal to 0. Let's do this further. This is x square plus y square minus 6x minus 2y plus 1 is the equation. That was the first equation. The second one is minus of x square plus y square plus 2x minus 8y plus 13 equal to 0. So let's submit minus inside for the second equation. So the first one I'm just writing as it is. So this I'm just submitting minus inside. So minus x square minus y square minus 2x plus 8y, this is minus 13 equal to 0. So let's cancel the similar terms, that is plus x square minus x square get cancelled, plus y square minus y square get cancelled. So minus xx minus 2x, that is minus 8x. So when it comes to y, minus 2y plus 8y, so that will be getting plus 6y. The values minus 13 plus 1, so we'll be getting for that minus 12 equal to 0. So here if I just take minus 2 common, so for that I can get 4x minus 3y plus 6 equal to 0. If I send minus 2 to other side, that is 0 by minus 2, which is 0. So the remaining equation we got 4x minus 3y plus 6 equal to 0. So this is the equation of the common tangents for both of the circles. So let's see the final figure. This is the first circle and this is the second circle, where both of these circles were touching externally, that we understood, and we even got the point of contact where these two circles were meeting. That point also we got, that is there above as we already solved, and we even got the tangent, the common tangent for both of the circles, that is 4x minus 3y plus 6 equal to 0 is the equation for this particular common tangent. So these are all the things which they asked us to find out, and we got the answer.